Hello, I'm Kevin Kelly. I'm the president of Mezzo Technologies, and I'll be talking about our program to build a microtube heat exchanger for the V22 Osprey. Slide 2. Mezzo makes microtube heat exchangers. These are basically hypodermic needles on the diameter about 1 millimeter, and we've been spending the last 15 years doing nothing but perfecting a whole wide variety of approaches to making these high performance heat exchangers. You can see from the slide that we make a wide variety: military, ground vehicles, aerospace, defense. We're getting ARPA-E with high pressure, high temperature. We got oil coolers, cryogenic, supercritical CO2 heat exchangers, just a wide range of heat exchangers. And we've got more programs coming down the pike. We really believe that our technology is suited for a general upgrade across a wider front of heat exchangers to help the defense community. And we hope that people are aware of us and give us a chance to introduce our technology in these applications. The slide below just simply shows some of our customers. I mean, we've got automotive racing is not particularly relevant to the defense community, but these teams want the very best, and Mezzo is the supplier of some of the highest performing intercoolers and oil coolers in the world. So we're at the Indy 500 and we're in Formula One, etc. In the low, you can see the Osprey program is something we're working on, an oil cooler that does not foul. When you land in sand and dust, the heat exchanger will not clog up and become non-functioning like the current unit does. Military ground vehicles, we've got a couple of programs there. We've got a number of customers in space and aerospace where we are providing weight savings and performance enhancements, etc. So this is just pictures of some of the customers we work with. Now, there's lots of different reasons people use our products. There's compactness, sometimes there's weight savings, performance enhancements. In the case of military ground vehicles, a lot of companies have gone to using our radiators, which have very low airside pressure drop, to achieving great savings in fan power. Our cores, liquid cores, are extremely compact and high performance. Our intercoolers for military ground vehicles have been tested, and they're very high performance. You see the Formula One stuff is shown that they are looking for the very best in performance, and we provide it in with an intercooler that has incredible efficiency and compactness. So these are some of the reasons that people are using us. We've had a multi-year contract with the NAVAIR. We've been designing a V22, an oil cooler for the V22, one oil cooler in each nacelle of the V22. It's a drop-in replacement for the current unit. Basically, the problem statement was to provide a product that provides all the thermal performance, the same weight, in every way at least equal, if not better, to the current unit, but to be much more resistant to fouling. A current unit gets clogged with sand and dust on the air side stream. The dirt gets clogged in the fins. Our unit with microtubes has wide open channels and is very easy to clean. So it doesn't clog and it's easy to maintain. So that's the main reason in this particular application that we've been working on this product for the last couple of years, and we're well on our way to building a product that's past qualification, provides the thermal performance and gives the resistance to sand and dust fouling. This slide is meant to explain in a very simple fashion what is a microtube heat exchanger. almost every product we make, they come in cylindrical form or rectangular form, but there's similarities between all the products. This is a very simple heat exchanger. The end cap has been taken off, and you can see, hundreds to thousands of tubes extend from one end of the heat exchanger to the other, from one header tank to the other. Those tubes, the tube sheet, where the tubes join to the header tank, there's various methods we use to bond those tubes to the tube sheet. We've got a polymeric bond we use for racing, and then we've got an all metal joint we use for aerospace and defense and applications where longevity and strength are required. But anyway, so the thousands of tubes extend from one end of the heat exchanger to the other, and usually there's those tubes pass through support plates. We call them mid plates. So each tube registers through mid plates, which also have the same number of holes as there are tubes, and they extend from one end to the other. So one fluid flows through on the inside of the tubes, and the other fluid flows over the outside of the tubes. If you look, this particular heat exchanger, which is typical of a lot of radiator applications, the tubes are sort of in line; they're in rows, and this configuration has surprisingly good heat transfer and pressure drop ratios. In other types of heat exchangers, the tubes might be close packed, and the pattern would look differently, and it all depends upon the application. Anyway, that's Mezzo's technology is related to the ability to make the key parts, the tube sheets, the mid plates, the ability to assemble these products quickly, the ability to seal the tubes to the tube sheets so that you don't have leakage, and to put on header tanks and add all the bells and whistles that make a high performance product. But that is basically what a microtube heat exchanger is. This simple little nerdy slide is to explain in very simplistic terms, why people use microtubes in the first place. And there's a number of ways of getting compact heat transfer. Mostly it has to do with increasing the area available for heat transfer. Microtubes are a subset of microchannel heat exchangers. All compact heat exchangers have progressively smaller channels. The microtube approach is a very good way to achieve a lot of the benefits of small scale and still have surprisingly good resistance to like airside fouling and other things that are a problem with small scale. So it's a good balance. It gives you a lot of the good stuff of small scale without some of the penalties. Anyway, from a real nerdy standpoint, if you had a bunch of microtubes or tubes, like conventional scale tubes, bigger, you might look like the first case, and then compare that to the case below where the tube diameter is half the top case. Well, in such a case, you could pack, if you drop the diameter of a tube by a factor of 2, you can put 4 tubes in the same space as you previously occupied with 1. So you've gotten a fourfold number in tubes. Now, each tube is half as big, so each of those small tubes only has half the circumference. So when you go through the little math, you'll find out that the area available for heat transfer is twice as big as the area. When you reduce the diameter of the tube by a factor of 2, you increase the surface area by a factor of 2. 4 times more tubes, but twice the surface area. But heat transfer is a function of both area and this thing called the convection coefficients, which is basically the heat transfer coefficients of the surfaces of the tubes. And from heat transfer calculations, you'll find that as the tube gets smaller, the heat transfer coefficient gets larger. So at the end of the day, the heat transfer is for all things being equal is proportional to 1 over the diameter squared. And in some cases, in other cases, it's maybe 1 over the diameter to the 3/2 or whatever. But this is a simple model, and it shows just the powerful scaling law associated with with tube size. So according to that, Q is proportional to 1 over d squared. If you drop the diameter of the tube by a factor of, say, 5, you went from a 5 millimeter diameter tube to a 1 millimeter diameter tube. The heat transfer per volume would go up by a factor of 25. So very powerful. And this is the Osprey V22 oil cooler that's been under development by Mezzo. That is an all stainless steel microtube heat exchanger that is, made to be a drop-in replacement for the existing aluminum finned heat exchanger that the NavAir is currently using. That product actually has 4 different heat exchangers in it. There's different types of oils, gearbox oils, engine oils, etc. Anyway, again, all the ports are identically located to the existing ports that are in the incumbent unit. There's that hole in the middle is where right in the middle of the unit is where a shaft actually goes right through the unit, and there's a fan on the backside that pulls air through the unit. That particular unit has been thermal tested. Its thermal performance equals or exceeds the current unit. Pressure drops are fine. All thermal performance metrics have been met. It's a stainless steel unit, and yet surprisingly it weighs almost exactly the same as the current all aluminum unit. It has passed shock and vibe. It's currently undergoing cyclic pressure testing of some of the intakes. But anyway, it's close to qualification. We hope to be going into flight tests soon. And we're working on things now like important things actually, like cost reduction of the caps and things like that. Anyway, the picture you can see, it provides, the one on the left provides the real reason for the whole project. You can see through the transparent nature of the heat exchanger. It almost looks, because of the inline tubes, the sand and dust passes right through it, and you can get it very, very, very tough, sandy, dirty environments, and this unit will not clog up. If you looked at the competing unit, you can't see through it. The tight fins capture grit and dirt, and after a fairly short period of operation in the wrong environment, you can have serious overheating problems of your oils. So this is the project that we've been working on. We think it has a lot of potential, and I might also say that we're this project and the developments of Mezzo is leading into developments across other Navy and military platforms, other helicopters, etc. So this is, we think, just the beginnings of what we think is a real important application for our technology. Mezzo's goal is to be a supplier of replacement units that the Navy or all the customers of the V22 would replace the existing units in a timely manner as they see fit. But we feel the benefits, especially like in a dirty environment or a real environment where there's people are landing in sandy and dirty environments, the benefits of our product when you really need this vehicle to function properly are going to be enormous. We're in the final stages of qualification right now. We did just win a few more $1 million to continue the work on this heat exchanger and to work on the productionization a little bit and maybe decrease the pricing of, or make our manufacturing process just a little bit more efficient. But we're well on our way to being ready to be a supplier of this product. We have built the, I believe, left-hand side, and we're waiting on this new funding to build a number of units for the right-hand side and supply the NavAir with multiple units of both sides of qualified units, and that's sort of the goal over the next year or two. But we want to transition to the fleet as soon as possible. Contact information for our company is on this slide. I'm the president, Kevin Kelly, doing this talk, and Charles Becknell, director of operations, who's also been running the Osprey program for the last few years. Phone numbers are attached, and we really do believe our product is good across a wide suite of applications, and we do hope that people contact us and allow us to introduce our technology into more and more places, because I think our Defense Department equipment will function better. That's all.